So we thought about, there was one reoccurring theme through this workshop, which was this question, how complex do our models need to be, or how much can our models be simplified? The simple models that run faster, or the complex model that represent human behavior in a better way? And please have a seat. I did something I'm sure I'm gonna be beaten up about, but I tried, for no particular reason, to sort the presentations that we had here in the order of complexity, where to the left side, of course, there are the faster running, simpler presentations, and to the right side, the more complex presentations. To the top of this line, I had those presentations that dealt with an entire integrated land use transport model. On the bottom, I had those presentations that picked a specific aspect of integrated land use transport modeling. What I found interesting, and I don't know if it means anything, that those colleagues from North America tended to be more on the right side. Those colleagues from Europe tended to be more on the left side. And I don't see a particular reason why that is, because I think the problems we are facing are comparable. To give this a little bit of context, I also asked the four panelists to look into these four dimensions, because I don't think it will be either complex models or simple models. I think both are going to exist in parallel, continue to exist in parallel. So I gave just four dimensions that came to mind to me that would be interesting to discuss this question. If you ask how I picked these four, I just selected those four with the largest number of gray hair. That was just the most senior people I put up here in the front. And I would say ladies first. So Pat, if you are willing to give us your statement.
Okay, I think I have four things to say other than another thank you to Rolf. Again, I think it was a very nice mix, and even your little timeline, which is very clever. Not timeline, but graph up there, illustrates the diversity of viewpoints and perspectives that you've assembled here. So I think you did a masterful job of picking people. Okay, vis-a-vis your questions, I guess one point is I really liked what Ali said yesterday or day before, and what Kai Nagel reinforced in his presentation. That is the idea of the simple interface, or the dashboard, as Kai put it. So that even if the models are very complicated underneath, having some way that ordinary people can interact with the models that's straightforward, much like when we flip a light switch, we don't really have to know about electricity and where the energy comes from, and when we turn on our cars, we don't have to know how to build one, and so on. So, you know, we do that sort of thing all the time, and I think making our complex models more accessible in terms of how to use and interpret them could be very helpful. Number two, you can see that I'm on the extreme right end of the scale there, and one perspective on that is that we've repeatedly said, well, things are changing rapidly. We need our models to be responsive to what policymakers want to know. And so whether it's prospective policies or just technological developments or trends in socioeconomic, demographic characteristics of society, seems to me there are a lot of questions we want our models to answer. And if it's simple, it may not be able to address those questions. For example, long ago, some of us are old enough to remember mode split stage of the four-step process, where the goal was simply to get rid of those troublesome transit trips as rapidly as possible and do the rest of the process on the car trips that were all that really mattered. So, of course, that evolved into mode choice models, where you actually tried to deal with transit as a real alternative, and transit networks and transit assignment. But even when we went that far, we didn't have pedestrian trips in the model, because who cared about those? And we were zones, and intra-zonal trips didn't matter. And eventually we realized that yes, they did matter. And so with each step of those more different or more complex or whatever questions we wanted to answer, the models had to become more complex to respond to that. So I don't really see a way to get around that. But that may lead me to point number 3, which is in some ways, well, I totally agree that we need both, so for some situations, the simpler model may be sufficient or may even be preferable, but it might be the case that we need the complex models in order to know how best to simplify to get to the simple models. So one example I gave Rolf this morning was the factor analyses that I do with the attitudinal variables, often involve 30 or more attitudinal statements from which I may derive 5 or 6 factors, each of which is a linear combination of the statements that are most closely associated with that underlying construct. Well, once I do that, maybe I really only need the 1 or 2 items that are most closely associated with the underlying construct. The rest are useful, but not, not essential necessarily. And so, but until I do that factor analysis and know which items are the most important, I don't know how to simplify from 30 to 6. And similarly with land use variables, you can have literally thousands, as we found out with our machine learning adventures, that you don't know which of those thousands of variables might actually be the most productive in helping you do what you want to do until you allow the model to include all of them and see how it turns out. So I think having complex models, but then thinking about them carefully to see how they can be simplified is useful, and it may well be that with a very flexible general model, you'll simplify it in one way for one purpose and in a different way for a different purpose, but that you're still able to work from more complicated to less. And I guess the last thing I wanted to say, I don't know how to say this without sound, it's a personal preference, not a normative statement, but I personally would prefer to work more on some kinds of complexity than on others. So I'll just put it this way, that our good friend Sergio Jaradias is the one I heard say this. I don't know if it's original to him or not, but he said in the discrete choice modeling world, there are 2 kinds of people, those who concentrate on the V and those who concentrate on the epsilon. And so, those who concentrate on the V are those who try to understand, the direct influences on behavior, and those who concentrate on the epsilon are those who try to, put more complexity into what we don't know and what we haven't observed and haven't measured. But, I'm not alone. People much higher stature than I in discrete choice modeling world say, we're better off trying to get the V as good as we can before we start trying to complicate the epsilon too much. So I personally would rather, try to think from a conceptual standpoint about what variables seem important to the choice at hand and try to do a good job of observing those variables and incorporating them into the models. And when we do that, we may not need a very complicated error term. As some have said, in discrete choice modeling, our goal is to get a multinomial logit model that we don't need to dress up with, nested logit or mixed logit or more complicated structures because we've adequately represented. So I'll stop there.
Okay. I did put just my stuff on a couple of slides just so I would remember what I wanted to say and also have some hope of sticking within my 5 minutes. When we got this assignment last night, thawing out in the hotel room after that's it there. So my first response to Rolf's 2 questions about simple versus complexity, my answer is yes. But obviously we need to do a bit more than that. I mean, I guess my starting point is that human behavior is fundamentally complex. And so the question we're all wrestling with is how to deal with that complexity. And I would argue that complexity and simplicity are not necessarily opposites of each other, and that complexity does not necessarily lead to computational inefficiency or burden. It depends on how we implement the complexity. In my experience, certainly disaggregation, if it's done properly, often simplifies the model and makes it more efficient. Just as there's sort of the V people and the epsilon people, if we approach a complex problem, I think historically we've tended to, try to simplify the context of the model, the contextual way we're framing it, and then we write extremely complicated algorithms and utility functions and so forth to try to capture the complexity in the behavior observed. Another approach is to maybe take the complexity hit in terms of trying to model the context and understand the environment within the decision making, and then I think what you often find are the decision models often become very simple. And so again, I think it's a strategy, a tactic of where do you put your effort, where do you get the complexity. I would also say I like to differentiate between complexity and complicatedness. You know, I mean, if chaos theory and complex systems theory has taught us anything, extraordinarily simple models can generate infinite complexity in behavior. And I think one challenge we have in our field is we build very complicated models, and I think we've seen that in, you know, and some of that's inevitable because we're trying to deal with things and with relatively simple tools, but I think, you know, when we hear David Simmons talking about how the British travel models are getting less and less and less and less efficient, is I think we're just adding a Rube Goldberg, you know, we keep adding boxes onto things rather than rethinking structures and trying to think through the problem. I mean, Kai and Rick and I have seen this, I think, in the California high-speed rail model, where they have a legacy model. Instead of kind of rethinking it, they just keep adding things to it, and the thing gets more and more difficult to deal with. I think this discussion of complexity versus, quote, simplicity also does have a little bit to do whether we're focusing on behavioral research where we want to understand and explain versus prediction and application. And I think, again, in our field, I think we tend to mix and match those two things together. Obviously, for application prediction, we want to have good explanatory behavioral power, but I think these are slightly different questions. And I also think there's what I call a social Heisenberg uncertainty principle. I mean, there's limitations on the information we're ever going to have to explain behavior. You know, we all know our problems in terms of data collection, but I think in terms of, again, at least in the forecasting application, I mean, you know, and I think, you know, all of us microsimulation and activity-based people, we talking about, well, going to the corner store to get the loaf of bread before we go, you know, out to visit friends at the pub. Are we really forecasting at that level into the future? Will we ever have that sort of information? So I think we have to think about the robustness of you know, our ability to, if we're trying to forecast in the future, what level of precision will we ever have about these things? And maybe simpler, quote unquote, more robust models will serve us better, at least in that forecasting environment. Computation time, we spent a lot of time talking about this, and I would argue that, again, I think what we have to do is take much more care with model design as we're putting our models together and our hypotheses and how we want to represent behavior. Before we get to the software, we have to think about, you know, will this allow us to compute? And I think a big problem we have with a lot of our, certainly our activity-based models, is that we have very elaborate behavioral structures that just do take forever to run. And I would argue, again, maybe descriptively those are fine, but as predictive tools, they're useless. And so again, from a complexity point of view, adding more variables into the utility function has these days almost zero computational hit. Modeling more agents, if you can model them in parallel, has almost no computational hit. The problem is we have a lot of interconnection. So when agents are interacting, dealing with markets, you know, and equilibration in systems, that's when we have to feedback, and this is where the computation problem still persists for us because these things don't necessarily parallelize well, and that's, you know, certainly I think in our current models that's where we take a hit. And the big example of this is the network models. I mean, the irony here is we're talking about transportation and land use. These transportation models are still big, and the network models are big. Modeling the behavioral choices, the activity choices, I mean, that's boom, that's fast. But then we go into the network and we spend forever simulating, and then we have to iterate through the whole thing over and over again. And I think that's our single biggest problem. And I think we have to deal with that, again, conceptually in terms of how we think about how we're going to model this before we ever write the software. I think integration problems are always going to be with us, and many of these things we don't even really think about, but just how mode and route choice interact, or mode or destination choice interact, that's an integration problem even within the same software. I mean, how do we represent these things? You know, and inevitably we have all these things we piecemeal out, even within travel demand. So I don't think there's, you know, that challenge is with us forever. And then as we go into land use, environmental model, energy modeling, we're looking at systems of systems, and I think the only way we can handle, again, these complex systems, in my view, is through decomposition, a reductionist approach. We piecemeal it out to solve individual problems, but then we have the problem of stitching these back together again. And again, that's, in the first instance, not even a software issue. I think specifically with respect to land use models, and this is something that really, I think, come home to me in this little workshop, is the the realization that virtually all land use models are one-offs. Marcel Echenique has his model, Alex Adams has his model, Paul Waddell has his model, Eric Miller has his model. David Simmons has his model. I mean, it's and yes, we learn from each other, but I don't think there's been the convergence and the ability to learn from each other, perhaps in the way that we need. And and we start to hear about, well, these models really aren't being used anymore. And what happens if somebody got run over by a bus? I think the survival of these models, more and more, I'm actually less optimistic about land use modeling than I have been in a long time. I think we do have to start converging. We start to have some critical mass. We have to have some convergence on this if we're going to accomplish anything. And I think the starting point is semantics, common semantics, ontology. Again, before we get to software, can we even agree on terms? Can we have sort of a conceptual structure at some pretty abstract level? We're working on an ontology for cities right now, and from this point of view, can we have at least model templates that we can work with? And I think modularization, as we move from our thinking to our programming, so that we can be swapping models, we can actually interchange things, even if we have to rewrite it in different software. This was the motivation of Opus. I think MatSim is probably the best example of this at the moment. Our own work, we have something called Extensible Travel Modeling Framework, where we're trying to do this. We're trying to write a system of modules that allow you to swap, and you can graphically, in a graphical interface, bring modules together to build your model system. Everything we're doing is within that at the moment. And then at Argonne, Polaris is the same idea. But the problem is we have now these silos, more or less silos of different people trying to do this same sort of integration. And I do think coupling is always going to be with us. And so software, I mean, again, I'm more convinced than ever by Kai Nagel and everybody else that I kind of wish we chose Java 20 years ago instead of, at the time, C++ and migrated to C#. But how do we solve this unless somebody, decides to bite the bullet and convert? I mean, I don't know. Will there be a winning language? Anyways, those are my comments. Thank you.
Well, Eric said everything I was going to say, and I'm hungry, so... Actually, this is kind of a bit of a scare for me because Julie and I have been in Europe now for 2 weeks, and this is kind of the end of it. And one of the things I've been doing is not paying attention to email at all. And so I only saw the email from Rolf this morning because I got online to look at this idea jumped in my head for one of my subordinates, and I thought, well, I got to send this off to him. And I saw Rolf's thing, and I was thinking, OMG. And so, but I totally agree with what's been said. What really encouraged me about this meeting was the fact that for the first time that I've been to an advanced modeling meeting in a long time, people talked about the policy context. And they spent a lot of time talking about it, like David did and Alistair did and everything else like that. And I find that really encouraging because I think that's going to be what drives decisions about whether you have lightweight versus heavyweight models and things of that nature. And the other thing that I thought was really encouraging were these compelling examples of these lightweight models, because everybody's been complaining about wanting a lightweight model for a long time. But between Kai's discussion and stuff that Michael Wegner was talking about, that's really encouraging, because I see a lot of this thing. But I do kind of go back to where Pat made the comment, is that we have a lot of reasons for building models, and some of them go from being able to talk to policymakers and others, behavioral research, and in some cases we're almost to the respect with activity-based modeling of virtual reality. We've lost the art of modeling, and why we're modeling, because we only want to know about a couple of things that really are important to know, rather than building a virtual, simulation of society, and so I'm really encouraged by that. I think that we really can do that, and I think that The question, though, isn't whether we should have one or the other. We definitely need to have both. But the challenge for me is, how do you go from one to the next? How do you take Pat's research and morph it into modelers like knuckle draggers like me can use when I go work in the public sector, and I'm trying to inform policymakers and investment bankers and all those folks. And that's the real gap that I see. And so now I see, like, we have some ideas here about some of these lightweight models that would work, and I see how information from advanced research will get into that. The other thing that I'm really anxious for is for some sort of a scalable platform that would enable us to do this. So we have MathSim. What if we had ILUTISim? And what I mean by that is, a consistent set of synthesizers of population, of land use, of firms, the sort of things that we do over and over again, because I totally agree with Kai Nagel, who said this is a huge waste of scientific time to keep reinventing all of this, the backplane of the models, if you will. We spend an inordinate amount of time building that when we could be making, very substantive contributions. And I'm so, and Kai, thank you for pointing out, the thing about the GeoServer and everything else like that. Something that gives you visualization without, strapping on a GIS and all the complexity that's associated with that. A couple of things that we didn't talk about that I think are really a key are, why do models fail? And kind of in the same vein, what about the life cycle of models? Can you really separate the developer from the model? And I think that's a very pressing issue that we have to face in terms of credibility. And I think that the credibility needs to not be just within our profession, but within the wider public policy arena in which we hope to inform. I think this whole idea that Kai asked yesterday about how do you create champions? We've got to create those sort of people. They're just they spontaneously turn up too infrequently for us to make huge progress with. I'd like to see some discussion about big data and how big data is going to influence everything we're doing, because it's fundamentally changing everything I'm doing. And my last question is kind of a challenge to you is, if we could all compromise on this one framework, and maybe we use some sort of a functional programming metaphor, so you could use your own models and everything else like that, and that could move us forward, would all of you be willing to buy into that and put aside the stuff you've created already?
Okie doke. Hard question. I think, nothing much to add, but I think the temptation we have as transport modelers, and the more social science oriented one among us, is to make the transport models in models of all of daily life. Certainly when we extend it from a network equilibrium to a schedule equilibrium, when I ask the question, okay, how much money is being spent and by whom, and how is that money divided between the group and who is meeting, we are very close to what he just said, virtual life. And I think this is very satisfying as an academic, but is that really what our customers want? And I think it's even worse for the land use modelers, because you're not only modeling daily life, you essentially model all of life, because when you ask the question, will the people buy the house, then you have to actually ask the question, can they afford the mortgage? And where do they get the money from? And does that fit into their overall life cycle planning? And will that be consistent with the expenditure which will be needed for the kids planned in that house? Will that all work out? So it's even worse. And never mind all the complexity on the developer side. And I think the temptation and the interest is there, but we have to ask ourselves, how bulky are the questions which really drive the development of an urban area? This is roads, and they're very bulky. This is highway lines and railway lines, and they're very bulky. This is new development areas around the city. They come bulky. They are not subtle little changes of adjusting the price by 2 cents. These are big things. And then the question, and no surprise, is that what I see in many applications is that the engineers and consultants then just build lumpy models. They don't care about the latest twist. They will just do what they have done since the 50s and be happy with it, because it has the added advantage that it's much easier to communicate with the public and the clients. So we have to really ask ourselves the question is, have we gone in the pursuit of some often very marginal policy tools into overcomplicating the models, as nice as they are academically? So that's one issue which I see here. And that was one of the reasons I wanted to do this MAD model, which I presented yesterday. So how do we bring that together? And I think your question at the end, would I be willing to give up what we have done? Probably for teaching, probably for application, for research, maybe after a while, after I've kind of sobbed and said, okay, not Matzim anymore, but whatever else. And to be honest, I don't have to worry about that much more anyway. So maybe, yes. But I certainly wouldn't stop developing that new approach, which is radically new, because yes, one has to have the chance for innovation, and that would then still happen. So, yes, we need the complex models to allow us to innovate and advance the social science insights we have in daily life, which is really in the end what transport behavior and transport engineers are doing. And we still have to provide models for the lumpy decisions which will be taken. And there, maybe pedestrian route choice is not very crucial if the city is deciding whether to build the next motorway or not.
And on behalf of all of us, I'd say that if we had known that you were going to use that particular criteria for selection, we would have dyed our hair.
Super, thank you. I'd like to open this if anybody else wants to comment on this question. Simplicity, complexity of models.
So I'd just like to elaborate on something that a question that I asked on the first day, which I didn't particularly eloquently pose. And that is, well, it's more of an observation, I suppose. So in my experience then, the task of model preparation takes orders of magnitude longer than the subsequent simulation. And there hasn't been too much discussion in the last couple of days about how we can go about efficiently preparing our models, how we can go about using emerging standards for the exchange and representation of data, so that once we've gone through that enormous task of acquiring data, sanitizing data, preparing scene descriptions, that effort can be reutilized. And I fully agree that there needs to be more kind of work in exploring the extent to which big data can be used in a productive way and enable us to sort of sort the wheat from the chaff.
Yeah, just to back that up, I guess, there are things like City GML that are attempts at standards of modeling buildings. Do we need or is there already a transport GML? Or should we be having a kind of transport model as OpenStreetMap, where we all contribute our network models to some kind of open mapping portal where we can just, if we want to model a particular city and somebody's already done it with their own model, and there's a standard format, can we just suck down a network representation so we don't have to go through this process of defining all the attributes on the links and doing all the rest of it again if somebody's already done it? I don't know how much effort it would be to set that up. Maybe it's diminishing returns again. And the big data question, I think, as well, Mike Batty at UCL has done a lot of work with things like Oyster card data and Twitter and the Boris bikes, and those kinds of data sources in themselves are very interesting. Are they useful? Maybe or maybe not, but things like mobile phone data as well could be. And I had a discussion last week with a chap from Telefonica, who in the UK is O2, and they have a third of the mobile phone market in the UK, so they could potentially provide a third of all of the people movements in the UK. They have them in their databases. And they can infer people's home locations and work locations and shopping locations from their data. Is that overload or is that useful? I mean, these are the kinds of questions I think we should be exploring as well.
The last bit of that is being pursued in that both Telefonica and Vodafone have subsidiaries which are setting up specifically to market that kind of data with different approaches. One of them is setting out to do the analysis, the others to provide more raw data, but that one is going ahead. But it seems to me that the critical bit is in, sort of, as you said, imputing where they live, which may or may not be where their phone is registered, if that data is associated with it, but certainly the question of whether people are going to work, to shop, to other family commitments, how that gets imputed is tricky, to put it mildly, because all you have is records of a phone being roughly somewhere at a very precise time. And the experience of the transport studies, which are trying to use that data, could charitably be described as mixed to date. What strikes me as the risk in that respect, which may apply to other fields as well, is that the belief, or the assumption that we can get everything we need for transport demand modelling from big data is going to make it more and more difficult to justify detailed surveys, attitudinal surveys, for example, which we clearly do need to supplement, if only to provide the basis for imputing the things that big data can't tell us directly. This is already becoming a problem. We're also seeing it in a different form in regard to the census. The once a decade struggle to make sure that we get a genuine census rather than a total reliance on administrative data, which will give us some but not all of the information.
The telcos have reams of data, and they have completely unrealistic expectations of the willingness to pay of their clients, which really becomes the issue then. And yes, there's lots of interesting information in there, and I think probably just about everybody on the room is working with this data, but there are certain limitations, and then in particular, their understanding of the willingness to pay.
I wanted to pick up something that David mentioned in his presentation, and that kind of I felt was, if he had said that in the U.S. amongst the group of activity-based model believers, would have been quite shocking. And we didn't really talk about it, which was his statement that he's reached the conclusion that we need still the deterministic models for certain types of applications. And we run the problem, or I guess we're, and I think, fortunately, and thanks to people like Rick, that I work in a company where we see, we interact both with folks like you that are working in doing research, and with also people that work for the public agencies. And oftentimes when we go and talk to them about the models and the results that we get from the models, we get some, oftentimes a fair amount of pushback from them, in which, not really out of ignorance, but more out of, I can't work with the way in which you want to present the model results. I can't do anything with that. And so we sort of find ourselves sometimes in this situation where we really do believe that we need the randomness and the stochasticity in the models to be able to say something that we feel is reasonable and intelligent about the policies, but yet on the other hand, our clients are telling us, I want a number, I want an answer. And so how do you deal with that, or how do you cope with that, and where do we go from, sort of move forward in that world?
Okay, that is a big question. I think I want to put this question into lunch, because I want to make sure that we have enough time to get lunch and wrap up. I want to thank the panel very much for giving your feedback. I really appreciate that you took the effort and put in the extra thinking to give some summarizing comments here. Thank you all so much for coming, and I wish you safe travels home, and I'm looking forward very, very much to continue to collaborate with all of you on integrated land use transport modeling. Thank you.